Hello. A little while ago I was given this. It's a Sony professional grade OLED studio monitor. It's got professional SDI digital inputs. It's a really decent piece of kit, but as you can see from the label, it's faulty with a flashing red LED. Let's see if we can find out what's wrong with it. Now I've looked at the service manual and it looks really promising. If you have a flashing red LED, plug it into a PC via a network cable and you can access information on the failure. All you need is the username and password that you'll get from your local Sony service centre. So that route is not going to work. However, you can get some information from the LEDs on panels on the inside of the unit. So let's take the back off and see what we can find out. And as ever with Sony equipment, they put these lovely little arrows here to tell you which screws to take out. Great. These screws are really tight. Wow, that is spectacularly tight. I don't think anyone's fiddled with this before. Okay, looking at this G2 panel, we have 4 indicator LEDs and there's lots of test points as well. But here, the panel is the other way around to the way it's shown on the schematics. But here's an LED 6228 right at the top there. And we've got a pair here, 6407 and 8, there they are. 2 LEDs there. And another one down here somewhere. 6229. So those LEDs indicate whether we've got 28 volts, 2 12.5 volt lines, and 6229 is AC off detect, output display, and AC monitoring. So that should be red. So let's see if any of those come on with the machine, with the power button pressed or not pressed. So I'll start with it not pressed. Okay, so we have the, I think that's off, that's what it's trying to say there, AC off detect and AC input monitoring red. So when I switch the front panel push button on now, that goes off, and the other 3 LEDs tell us that the 12.5 volt and 28 volt lines are present. I could actually meter them as well because we do have lots of good test points, so I will switch it off again. Okay, the other big panel PCB in here is underneath here, but it's sold as the whole unit with the OLED display, so I think they're saying that that's kind of a non-serviceable item. Alright, we'll measure those various test points on there. Okay, so let's measure the voltages on the 12.5 volt lines and over here on the 28 volt line. Power it up. 28 volts. Yes. Okay, the upper 12.5 volt line. That looks good. And the lower 12.5 volt line. Looks good as well. So no problems with those supplies. It's not looking like a power supply fault. There are other supply voltages, 3.3, 1.5, 5 and 1.2 volts, but they, and 1.8 maybe, they appear to be generated on the panel that's underneath. So, well, we can have a look at the panel underneath, but we can't do terribly much about anything we find on that. One thing I've been told, though, is sometimes reseating these connectors can make this whole thing spring into life. So I will refit these connectors just in case there's a connector issue. Okay, there's only those 2, the rest is just DC in. I don't think this is at all likely, do you? Okay, I'll power it up again. Wait for the flashing red LED down there. It went green and then flashing red. I'm going to shoot this bit in the dark because the next thing to check is for some LEDs on the QBC board. But the trouble with the QBC board is that whatever of the 3 LEDs you find are on, it's time to replace the entire OLED panel anyway. And it involves a lot of stripping down even to get to those LEDs. And I don't even think I would be able to connect up the power supply terribly easily to the QBC board when it's stripped down. So I don't think it's worth doing all that stripping down. So what I'm going to see, and this may not work, is I'm going to switch off all the lights in the workshop and power it. It's powered up now, but switch it on at the front panel and see if I can see any LEDs anywhere shining through anywhere. I don't work which way round the QBC board is mounted, but let's see if we can see any LEDs on there. So let's make it as dark as possible here. Right, so the only LED you can see at the moment is that red LED, which is saying that the power is off. Or it's switched off. So I switch it on and our 2 green LEDs come on. Now can I see any hint of LEDs shining through in the board underneath? And I don't believe I can, which probably just means I can't access them. No, the only LED I can see any hint of is a red LED at the bottom, which is the power one flashing. We can't see anything else going on. Any other lights you're seeing there are reflections in my workshop. So, unfortunately, it doesn't matter which, if any, of those 3 LEDs are lit, because whatever of those LEDs may or may not be lit, the fault is on the QBC panel or the OLED display, which is supposed to be replaced as a single item. And that, of course, would be ridiculously expensive. There's no schematics or any information at all on that QBC board, so little I can't even work out the orientation of where the LEDs are. So the only thing that they will let you service is the power supply, the G2 board, and even there they reckon you should just replace it, whatever's wrong with it. There's a little bit limited service information on this, and it looks like this one's a dead loss. Right, so the QBC board is part of the OLED panel assembly, and getting to that is extremely difficult. At least according to the service manual, you have to strip everything off this, right down to the speaker and the fans and the power supply board and every connector. Everything has to come off. Well, I think the service manual is wrong. I think they're saying that this is the order you would take those items down in, and some of those items need to be disconnected, but they've just said remove where they mean disconnect. So it would be a lot of work if you did it as per the service manual. Maybe we could bypass it, but at the end we're still not going to get anywhere because we can't fix any of that. But come on, we want to see what's inside this, don't we? So let's carry on in the interest of science. So one thing I'm going to do is take the feet off and put it on its front. I believe we need to take these screws out in order to release the bezel assembly, and that's going to be prerequisite in order to be able to get, I think, these screws out and be able to separate the chassis from the OLED panel. And of course a lot of these connectors needs to come off as well. So there's a lot to do for very little gain, but let's carry on. So we're certainly going to have to remove any connectors that go to the main board underneath. So we can start with that. Right, there's a couple in there, a fan one here, and those to the power supply. Then there must be another fan one here somewhere. Oh, does that actually mean we do have to take the power supply off just to be able to unplug the fan from in there? Oh, what a horrible design. Okay, power supply comes off then. You get the feeling Sony didn't really want anyone to repair this. Can we get the power supply out now? Okay, so power supply board removed. That's a very seriously thick piece of PCB. Now we can unplug the fan from underneath. We'll probably have to unplug various connectors here, but how many of those we don't yet know. So I'm trying to work out what we have to do to take the bezel off. It says there are 9 of these screws to remove, but I count 4 along the top, 5, 6, 7, 8, 9, 10, 11 of them. So I've got the wrong screws, or have they made a mistake? Let's take them out. Does that mean we can now remove the bezel? Okay, some more cables to undo. I think this is a speaker cable and it's awkward as anything. I might indeed remove the speaker. Okay, I managed to disconnect the whole of the speaker assembly so we can come up with the main chassis. So we can take this off, I think. So what's necessary to take this off? Well, we just don't know. The diagrams are just not that clear, a little bit overcomplicated, and they say you need to remove things like these fans, which I'm sure you don't, fairly sure. So, do we gain anything looking at that? No. It's just this edge. So I think I need to take these screws out, and I think these big screws at the back here, and we'll have to see what comes off, won't we? Start with these big ones, shall we? At the end of all this, my question is, am I going to have enough left that I can power it up and see what LEDs light up on the board underneath, on the OLED assembly? Am I going to have to remove these screws here from the HDMI socket? I suspect I will, because it looks like they go through to the board underneath, and there's one more screw in the middle there. Okay, so let's undo these screws for the connectors, and let's see where we are in terms of separating the this chassis from the OLED panel. Okay, going nowhere. Should we take the fans off? It does say we should, but we may need to have them removed later if we want to connect this system up and test it. So, is there anything I've missed that is stopping us from separating this chassis from the OLED panel? Sticky tape, I think. And on the other side, anything else? Another screw underneath. Ah. Okay, we've managed to split the panel apart. At last, now we can see the OLED driver board. Let's give you a better view of that. So wow, we managed to get into this thing. They don't treat this board as replaceable, I dare say, because there's so much calibration, quite apart from the connectors. I think it's a calibration thing. So they treat this whole OLED panel as one replaceable item. They've marked out 3 ICs, and we need to orientate ourselves with those. So this is IC 5000 apparently. Right. Then there's a 6101, which is presumably under here, and an 8000, which is presumably around here. Okay. That looks right. But that's not very helpful, is it? Because they're under a heatsink, so how is anyone supposed to know that? Really, they could have made a better job of this service manual. So there should be an LED up here, 7600, which I might have been able to see through there earlier. And another one around here somewhere, and another one over here somewhere. Right, let's see if we can find those. Okay, I have found those 3 LEDs, and they're not even marked on the board. What a horrible bit of work, Sony. There's 7600, presumably, which is this one here, but they haven't labelled it. Then there's another one down here. There. Again, they're not labelled it, which is 5201. And then there's 8400, which is over here by the heatsink, and again not labelled. And if any of those LEDs light, then it's telling you that there's either a failure of the FPGA, in which case replace it, or there's a failure of some of the power supplies on this board, in which case replace it, or there's a failure on some different lines and power supplies on this board, in which case replace it, which is why this is futile. But let's see if we can put enough of this system together now that we can power this up and see if any of those lights come on. It's going to be awkward because I'll need the front panel, the power button, so I'm going to have to get the cabling for that, which is over here at the minute, and connect up the front panel. So I'm going to have to strip that off the bezel, and we're going to have to connect up pretty much everything. I mean, maybe I can miss out the speaker, but pretty much everything's going to have to be plugged back in, which is a bit horrendous. Right, leave me to work on that, and let's see where we get to. Okay, so I have stripped everything off and reconnected absolutely everything, including the headphone socket with the speaker, the front panel controls which we need for this on-off switch. Then we have the OLED panel here, which I've connected now to. I've even connected the fans back up, lest we get error messages for those. And then this is the power supply cable up here, and then mains input up here. So absolutely everything is connected, and what we're looking for are the LEDs, which are very badly marked, well, not marked at all. So there's one there, so that's 7600, which would tell us if we have some power supply failures. Then one here, which is 5201, which would tell us if we have FPGA failure. And then there's one here, which is 8400, and that would tell us if we have some different power supplies and some signals missing. So let's see if we get any of those lights when I power this up and switch this on. I'm inclined to actually switch it on now, and I'll also switch off some of the studio lights to make the LEDs a little clearer. Okay, so we're ready to power up, and I'm inclined to not touch anything, just switch it on and see what we get. And I say I've already switched this socket, this switch on here. So let's just power it up, and we have red light over there. We had an amber one there, but it went out. So we have the red light over there, which is 8400, which is telling us that we may have some supplies missing. I'll just do that process again now. We're in the standby state. Power up and switch this on and just confirm the same thing happens. So we amber here, then that goes out, and red light over here, which I hope you can see, which is telling us we have possible power supply faults. That's the 8400 LED. Let's get you in on that one. Hopefully you can see that. So maybe we're missing some of the low voltages. Are they marked up on the board so we could see which? Right, I have some regulators here. Well, I think they're regulators, aren't they? Low voltage regulators. I don't know what the voltages are. I don't know what the terminals are. But we could have a look at those, couldn't we? It's all very scary the way this is all hooked up at the minute. But let's just see if I can measure any voltages around those three regulators. So as this is the 8400 LED, we're looking for 1, 1.5, 1.8 and 3.3 volts. We're only seeing 3 regulators there. But let's see, I'm assuming they might be the 1, 1.5 and 1.8 volt ones. Let's see what we can find. And I don't know what the pinout is of these either. And there's all kinds of things that could electrocute me or blow up here, so it's all a little bit scary. Right, so I'm going to power up now. So you're reading the voltages with me. Nothing much on that. Are these maybe not regulators? Maybe they're not. 0.07 volts on that. Not very much, is it? There's our LED complaining about something. All looks extremely dead. Not seeing any significant voltages anywhere. There must be something on the LED. Yes. But everything else looks pretty dead. 28 volts. We finally see a voltage. I'm thinking this might be a good moment to crack out the thermal imaging camera. Okay, I'm going to power this up again with a thermal imaging camera looking around the power supply, especially around where that 28 volts went in and never seemed to emerge again. So back to having that red LED on there. We'll leave it for a little while and see if something gets very hot. You can get reflections which give you bad readings, so I've got a bit of a reflection going on there over the heatsink, but we're ignoring that. We're looking just for any component that gets particularly hot. There's plenty of heat going on in the power supply over there, which you'd expect, right? It's a bit out of your shot, but the power supply is up there and you'd expect things to be getting warm up there. But we're looking for heat down here. There's a lot of heat in that big chip, but I don't think that's unusual. What reading are we getting on there? Well, 43 Celsius. No, that's quite hot. No. So there's some heat coming out from the ICs underneath the big heatsink, as you might expect. I was looking for some power component getting very hot. No. Just a bit from that IC, as you might expect. That was all fairly inconclusive. I didn't see any heat coming out from under here. That IC was getting fairly warm, but, you know, not that hot. It's fine. There were items marked F here as though they're fuses, but they didn't appear to be fuses. It almost feels like the coils are in fact fuses, and I've tested all those for continuity and they're fine. There's also some very low value resistors in places here, and maybe they're supposed to act as fuses, and again they all appear to meter out fine. So I'm seeing voltages going into this IC here, nothing leaving it. There's some transistors or ICs here as well, nothing coming out of any of that. So it looks like the fault could be in or around this IC, but we're working completely blind without schematics, and I'm afraid we could be done for. Though the service manual doesn't carry any schematics for this panel, it does have some block diagrams of the signal processing, which probably aren't relevant, but also power supply arrangements. And it shows you the two 12.5 volt lines and how they get split into various different other lines and which ICs are responsible for those. But we don't have any information on where those ICs are. And then we have two LEDs that can indicate power supply failures, one here and one over there, and they are associated with different lines, and it appears that most of the ones associated with this 12.5 volt line are on the 7600 LED, which is not lit, so that's not a problem, and some are associated with the 8400, which is the one that is lit, and they're mostly associated with this connector here, the pin 8 of 4007, which comes in the top here, but at least one appears to be arising from the other 12.5 volt line, if this is correct. having found some mistakes in the service manual so far, you can't take that for granted. So what I'd like to do is see if I can find these ICs anywhere on the board, and I've had a look and found none of them so far. I have found one or two of these. So what I think I'd like to do is start by just making sure I know what I'm doing and measure, say, a couple of the voltages from some of these ICs, if we can find them, that are not apparently defective because 7600 LED is not lit. Once I've done that, I can go search for the other ICs which may be under this heatsink. So we have to take that off and see if we can find some of these regulators under there and maybe monitor the voltages on those. What I have set up here is the multimeter is ready to measure. We're going to look at this regulator here, which is 7616, and if that were failing to produce an output, this LED here would come on, and that's not coming on. So this should give us good readings, and that'd be a good check that we're doing this correctly. So what I've set up here is we're going to look at one of the regulators which apparently is working, or at least it's not giving us an error message on D7600. The D7600 LED is up here and that one is not lighting up. But by starting with this one we should get a feel for what we're trying to do. So we have one of these regulators. The first thing I'd like to do is measure what input voltage we get. The trouble is my probe, looks small here, but it's the size of a truck compared to this thing. So let's see what we can see any input voltage. So pins 13 and 14 of this regulator are input voltage. It seems to be pin 15 as well, but we'll ignore that. That's the way I've wired it. So let's see if we see an input voltage when I switch on. I'm going straight. This switch here is in the on position. The switch on the front panel. So let's see if we see any input voltage to this regulator. Yes, we've got 12.4 volts. Right, I should be able to see 5 volts standby on, but that will depend if the IC is being instructed to be on. And it's also rather hard to get to because it's here and it's on a via, and I don't know if I can actually meter the vias properly. It's almost like it's got a conformal coating on this board, which makes it rather hard. But is there any voltage on there? And there's 5.5 volts on there. For some reason, this seems to be, this whole unit is generating an interference which is stopping the Bluetooth from working on my multimeter. How annoying is that? So at least we know that we have that regulator working. So now we can go look for more regulators under the heatsink, bearing in mind that the multimeter may or may not give us any readings on this display. Right, let's take this heatsink off. It's somewhat glued down to the ICs, I think. Okay, sticky padded down to the IC. Are there regulators in there? So that's the big IC under the heatsink. So we're looking for IC76 anything really, which will be regulator. Okay, there's one IC7612. Is that one of our relevant ones? Yes. It should give us a 1 volt output. We don't know what TC means. STB probably means standby, but we don't know what TC means. But there we have one of the regulators we need to access. Is it the same kind of IC? Okay, so this is IC7612 and it should be 1 volt. I believe that's our output and we'll be looking for 1 volt. Perhaps I should start by looking at the input, which I think with these pins at the top. So let's switch that on, see if we have input voltage. Yes, we have 12.4 volts in, and our output voltage I think is on this pin here. 5.5 volts out. Okay, but it's a 5.5 volt output, isn't it, on this IC? So the IC is working properly. It must derive 1 volt from that somewhere else. Okay, so we've ticked off that 7612 is working. We've got several others we would like to try to find. Okay, we've found another one, 7614, which should be responsible for 1.5 volts, but again we know it's going to produce 5 volts and it'll be taken down from there, and we can't find that circuitry, but at least we've found a regulator IC, so we can have a look around this one. Look at the input and output voltages. This one seems to be rotated, so pin 2 will be along the top there. Again, it's all very scary because we don't have a lot of space. Right, that should be our input voltage there. Let's see what we measure. So probably about 12 volts or so. 12.4 volts, yes. And our output should be, we think, here. And again, we'll be looking at 5.5 volts there because it's 5.5 volt regulator. Correct. So that is 7614 tested as far as we can go. I see 8600 we have, which should give -6 volts out. This is a completely different kind of regulator. We'll have to look at the pin out. Right, this one's going to be a little bit harder because, well, the output's actually input, which is pin 10. It's high side power MOSFET, so yeah, it regulates on that pin there. So we'll have to look at the output, which is the power input. So pin 2 is the input and pin 10 is kind of the output. Some supply voltage there. Let's check for that. 12 volts, 12.5 volts, good. And now some controlled output. I'm very mindful of getting a shock here as well. There's all kinds of things that could zap me. Nothing out. Right. We are zooming in on the fault, I think. Well, let's look at this IC. Below 1.2 volts to disable, float to enable on pin 3. Okay, that's set to disable, so it's not a fault in itself, it's being told to not run. Okay, I'm going to stop there for a minute because everything that we need access to under the heatsink I think we've had access to. So I'll put that heatsink back there now. So the point we've got to is there's a -6 volt regulator chip, TPS 54040, which is being disabled. And we think that that's being disabled by some signal that's telling it to not start up. So it's a dead loss, right? But I'm kind of at the point of nothing to lose. So maybe if I use a resistor to see if I can pull that voltage a little higher and get it above the 1.2 volts enable voltage, we could at least see if the red LED that indicates that the some of the lines are missing goes out, and maybe the panel will do something. Now you could argue, well, I could damage something. Yes, I could, but so long as I use sensibly valued resistors, the odds are I'm not going to damage whatever's feeding that. And anyway, what more can we do, because there are no schematics for this board? So it's unlikely that anyone's going to come up with any great brilliant ideas of anything else that I can try at this point. I've gone down to component level, you know, I've managed to find a signal that's incorrect, but without further diagrams there's no more debugging I can do. So I will consider adding a resistor to that to pull it high. I'll have to take it to the 12.5 volt line, so I'll have to use a suitable value resistor. I'll have to think about what value. The problem is that sounds okay, sounds easy enough to do, and when you look at down the microscope it looks easy enough to do, but in reality all my tools are like tree trunks compared to this thing. So soldering to that point is going to be challenging. So that's going to be my first problem. Can I solder, say, some wires to that pin and the 24 volt area? Well, that should be easy enough, and come up with a suitable resistor value to link them and see if I can get that enable voltage high enough to operate the IC. Now, as it happens, that IC is just beyond the edge of the heatsink, so it doesn't matter that I've put the heatsink back. So our first challenge then is, can we get to pin 3 of that IC? Because it just goes straight to a via. It's very hard to access. How am I going to get a contact with that? I mean, look at a little bit of thin wire I have here, and then see what that looks like compared to the IC. Tree trunk. If I was to try to solder directly to the IC, I'm guaranteed to get solder spill onto the adjacent pins. And here we've got the via, and I can't solder to that. Oh, how am I going to make contact with that? I have a whisker of copper from some desolder braid. That's thin enough. But could I solder that on there? Well, with the best will in the world, I'm not going to be able to solder to that via. My best bet might be to connect a resistor to this dentist pick, and then I can pop it there. So if I did that, that would make the contact, just to see if the LED, which is nearby, is just there, if that LED would then go out. And what value resistor? I've got 12 volts input. I don't want to blow up a IC that's feeding it. What value resistor do you think? Let's measure the resistance, just the cold DC resistance to ground on that pin. 2.2k, 2.3k, something like that. So we could take a bit of a punt. If we were to put 5k to 12 volts, that would probably get it up to, I mean, it depends, you know, that whether that 2k remains, but it would probably get us up to a voltage which would get it out of the reset condition. So let's put 4k7 between the 12 volt line, any of the 12 volt lines, and this probe. Okay, I've got 12.5 volt test point here, feeding through to a 4k7 resistor, which is then feeding through to my probe, and the multimeter is looking at the voltage on the probe as well, which of course an off load will be 12.5 volts, and I'm going to connect it to that via once I've got the machine powered, and we're going to see if anything happens. Or should I sit on the via from the get-go? I might do that, you know. And we're going to see if that LED is extinguished. So that's our enable pin. Let's monitor the voltage we see on that when I power this up. And also monitor the LED. The LED still lights, but we go up to 5.6 volts. So that should have got the chip out of that condition, but the LED still lights. So that is the end of that. Well, that was a fun experiment, wasn't it? So I went really a bit above and beyond what was sensible with this, just to prove the point and do some proper fault finding for YouTube guys, but the chances of ever fixing it were marginal at best. If anybody had one of these panels, well, I know the calibration data and stuff would be wrong, but it might be an interesting experiment to see if we could fit it. So if anyone has one of these panels from a monitor that's been smashed perhaps, please let me know. That might be one route forward. I'll do plenty more content on audio and video technology in the near future. Bye for now. thank you for watching right the way through to the end. I'm going to do little recordings at the end of my videos in future for those who can be bothered to get here. Do you think I should replace that regulator chip? If it's faulty, maybe we would have the symptoms we have. It's a little fiddly to change, but I should be able to do it. And it's thousands of pounds worth of kit. So what would you do? Let me know in the comments.